remote frame basically which is used requesting the data from other nodes. So like I mentioned earlier, there is advantage of requesting the data. Okay, so that means if two nodes, if ABS is sending a data to an airbag ECU continuously, then it will load the bus. Instead of that, then airbag just sends a remote request. Whenever the remote request is received, that time ABS will respond with the data. So this will greatly reduce the bus load. Okay, and then the third one is the error frame. Okay, there are about 5 different types of errors are detected in the CAN bus. If one or more errors are detected, the transmission is aborted. This prevents all other stations or nodes from accepting the message. Okay, so if any node in the network, if it detects any kind of error, it could be a bit error, it could be acknowledgement error, it could be CRC error, or whatever error it detects, immediately it will send an error frame. On receiving the error frame, all other nodes will also send error frame. Okay, I will tell you why all other nodes also send a error frame. Okay, so once the error frame is once the error is detected, error frame is sent on the bus. So there is a possibility of retransmitting the lost messages. If error continues, then the stations or node may switch off itself to prevent the bus from being tied up. So we will discuss more about this. This talks about the CAN bus fault confinement. Okay, so at a broader level, there are two levels of errors are detected. One is at the message level, another at a bit level. Okay, at a message level, just now we have seen the data frame format. So in that, at a message level, these are the different types of errors detected, like CRC error. Okay, now the CRC sequence is calculated right from the start of frame till the data bytes. Okay, so 15-bit CRC sequence is sent by the transmitter, and that will be checked again at the receiving end. Okay, whichever node receives that, again it uses the same polynomial and check that CRC. If doesn't match, then it will generate an error frame. Okay, that is termed as a CRC error. Then the frame check error. Some bits in CAN, like you have seen IDE and R0 are sent as fixed format. They will not change. Whatever may be the reason, they will not change. They will be transmitted as a dominant bits. Okay, so they have to be dominant, otherwise then it becomes a frame check error. Then I also discussed about acknowledgement error. If none of the nodes acknowledge the transmitter, then it becomes an acknowledgement error. And at bit level, every node in the network, when it sends a bit, either it could be dominant or a recessive, it will sense it back. If it doesn't match, then it becomes a bit error. But in case of acknowledgement, it waits, it sends a recessive bit, but it expects a dominant bit. Then bit stuffing. So what is bit stuffing? Mentioned here. After 5 consecutive equal bits, the transmitter will insert another bit which is a complement of this 5 consecutive bit, whether it is dominant or recessive. So in CAN, no node can send continuous, dominant and recessive bits. If it sends, that means it is termed as an error frame. Okay. Okay, good. Now coming to error frame. So there are two types of error frames are transmitted in CAN. Okay, there are two types of error frames. One is active error frame, another is a passive error frame. Okay, There are two types of error frames. One is the active error frame and another is passive error frame. Okay, listen carefully. So this is a very interesting topic. The node which are more corrupt, okay, the nodes which are more corrupt, they send a passive error frame. The nodes which are less corrupt will send a active error frame. Okay, you can see this is active error frame. Basically, active error frame consists of a 6 consecutive dominant bit followed by 8 recessive bits. Okay, active error frame consists of 6 consecutive dominant bits. As you can see in this figure, error frame, okay, active error frame consists of 6 consecutive dominant bits followed by 8 consecutive recessive bits. Okay, in case of passive error frame, it will be 6 consecutive recessive followed by 8 consecutive recessive bits. Okay, and then you can see it is not only just a 6 consecutive recessive bits, but it is a superposition of all the error frames from all the nodes. Why it happens in CAN? Why it is a superposition of all error frames? Because see, in CAN there is a concept, just now I explained that there is a concept called bit stuffing. Okay, so no node is allowed to send 6 consecutive recessive or a dominant bit. Okay, but error frame itself is a 6 consecutive dominant bits. Okay, so on receiving 6 consecutive dominant bits or a 6 consecutive recessive bit, error frame is generated. Okay, so when this error frame is generated, so that means it's a 6 consecutive dominant bits. So all other nodes on the network will also send an error frame. On the network, whichever frame receives the error frame, it also sends the error frame again. Okay, that is the reason it is a superposition of all the error flags, then followed by an delimiters. Okay, so basically each node will send a 6 consecutive dominant bits followed by 8 recessive bits. So this is the active error frame. Then coming to passive error frame, the nodes which are more corrupt. Okay, I will tell you exactly what is the error count. Based on the error count, they will become active error or passive error. The nodes which are more corrupt will send a passive error frame. So in the next slide, probably we will discuss how they send active error frame and a passive error frame. Okay, overload frame is also similar to the active error frame. Here also it is a 6 consecutive dominant bits followed by 8 recessive bits. Okay, it's a 6 consecutive dominant bits followed by 8 consecutive recessive bits. Basically, overload frame is used for used by the slower nodes. In reality, overload frames are not really used so much. Okay, but it can be used for slower nodes. Okay, is it clear? Is it clear? Okay, so this is a very excellent feature in CAN. I kept on saying. Now let us discuss this fault confinement in CAN. Okay, so can you see this figure here? Okay, so there are 3 states in CAN. One is every node has got these 3 states: active, error passive, and bus off. These are the 3 different modes of CAN controller. Okay, so and each and every node in the network has got this TEC and REC, that is transmit error count and a receive error count. Okay, that means whenever there is a successful transmission of the message, then this counter TEC will decrement. Okay, whenever there is a successful reception of the message, then this REC counter will decrement. Okay, and the same way, whenever there is a error during transmission, then this counter will increment. Okay, similarly REC will increment if there is an error in the reception. Okay, based on these two counters, the CAN controller state is decided. Okay, if both the counter values are less than 127, transmit error count and a receive error count, both the counters are less than 127, then it is the CAN node will be error active node. Okay, if both the counters are less than 127, then that node is a error active node. The node which is error active will send active error frame. Okay, active error frame means it is 6 dominant bits, then 8 recessive bits. That is the error frame, active error frame. The node which is error active, it will send a error active frame. Now, if these counters are not less than 127, if any one of the counter is greater than 127, then that node will become a error passive node. The error passive node will send a passive error frame. Okay, are you able to distinguish between passive error frame and active error frame? So passive error frame will be 6 recessive bits followed by 8 recessive bits. Okay, so what is the advantage? Why the node which is more corrupt, right? The error active node is less corrupt. By default, all the nodes will be error active. But as the error counters increment, they become error passive. Now here, error passive nodes are sending recessive bits. Error passive nodes are sending only recessive bits. What is the advantage of that? Can anyone tell me what is the advantage of using error passive frame? Passive error frame. Like I mentioned, passive error frame sends only recessive bits. Okay, and CAN is a wired AND logic. Okay, basically it's a wired AND logic. That means recessive bits will not have any impact on the bus. If any faulty node starts sending recessive bits, okay, if any faulty node starts sending a recessive continuously, okay, so it is sending 1. If any other node sends 1, then the same data will be there on the bus. If any other node sends 0, the node which is good, if it sends a dominant bit, then the bus will have a dominant bit. So that means it has no impact on the bus. So that is the reason, to keep away the faulty nodes from corrupting the bus, this passive error frame is being used. But the node which is sending a passive error frame, the error counters go on incrementing. Okay, once the error counters go on incrementing, and if this transmit error counts, can you see here, if the transmit error counts crosses 255, then this will switch off from the network. Automatically it will switch off from itself. No need to control that node, faulty node. It will automatically switches off itself from the network. The faulty node. See, this can happen because of if there is a loose connection in the CAN lines, and this can happen. The transmit error count may increment. Okay. So if the transmit error count increment and if it crosses 255, then that particular node will switches off from the network. That means there is no communication. It will not send any frame further, but it will keep on listening to the bus. Okay, so this is the biggest advantage Okay, faulty nodes automatically switching off from the network has a very good advantage, so it will not disturb any other nodes. Okay, that's the advantage. And more to that is that it will not send any data on the bus, but it will keep on listening to the bus, and if it successfully receives, after switching off from the network, if it successfully receives occurrences 128 occurrences of 11 consecutive recessive bits. Okay, 128 occurrences of 11 consecutive recessive bits, then it can come back to again communication. That is the biggest advantage. The node which was switched off from the network because of some faulty condition can again come back to communication. It's a really big advantage. It's a wonderful feature, I feel. Okay, and this can also happen because of a loose connection in CAN high and CAN low of CAN bus. Okay, or it can come back again after the reset. So by default, whenever CAN nodes are reset, they become error active nodes. Okay, is that clear? It's a very good feature of CAN, I feel.